Recording in progress.
Dilip, host बना दो please. Thank you. Guys, just give me a moment. I got caught up with some work. Okay. Yesterday, we had started on this topic of batteries. And before we continue, I hope you can hear me clearly and can see the screen also clearly.
Good morning, sir.
Very good morning. Thank you. Okay, so just a very quick recap on what we did yesterday. First and foremost, a battery per se. If you ask what is a battery, it's a combination of two or more cells, whether it is in series, whether it is in parallel or series parallel combination. Okay. Then we saw what is the definition of ampere hour and why a battery is rated in ampere hours. Okay, first and foremost, an ampere hour is a charge. Your AC is converted into DC and stored as a charge in a chemical form in that particular battery. Okay, so when that battery is going to be discharged, how many amperes it is going to be delivering for how many hours? Okay, so that is the ampere hour capacity, because depending on the load, you are going to discharge the that battery faster. In other words, more current is going to flow. And if you're going to take only the ampere hour definition, then it is 1 ampere flowing in 1 hour. Okay, and since we saw that batteries are used as a standby source on board ship, forget about a show. Whenever something with regard to anything related to the ship, one has to refer solar. So solar governs a lot of things on board the ship. And one of these is your battery as well as your battery room. Okay, solar chapter 2-1 part D, in particular, regulation 42 and 43. Okay. Then we saw very briefly what is a primary cell. The dry cell is a primary cell. Okay, we won't go too much into that. I only mention it in passing because sometimes they may ask you. They have asked it only once in a distant past. Okay, not to say that they will not ask it again. So therefore, I had described that to you yesterday. Okay, we saw the advantages, and then we came to the secondary cell, the wet cells, and this is what we are going to be concerned with, because we are having These two types of cells generally on board the ship. One is your lead acid type and the other one is the nickel cadmium type or the alkaline type. Okay, of which number one, the lead acid type is most commonly used on board the ship. Okay, so most of your questions are directed to that, but not to say that nickel cadmium type or the alkaline type is not available for onboard use. It is, and therefore questions are asked on that as well. Okay, so always sometimes they ask, how would you know certain things about your nickel cadmium cell? And of course, if you do not know, then this is related to safety. Remember, it is acting as a backup source. Okay, so it is a safety issue, right? So very quickly, what was the secondary cell? That it is going to be stored, AC is going to be stored as a charge in that particular battery in the form of a chemical thing. And then when it is connected to a load, a chemical reaction takes place. And then that cell or that battery, meaning a bank of cells, whether in series, parallel or series parallel combination, will be delivering that current, that charge in the form of electric current to that load. And therefore, depending on the load, it is going to get discharged. So therefore, we must restore it to its original form. And we saw, as far as your lead acid batteries are concerned, we saw how that was taking place, before which these are the parameters which are very, very important. Very important from the point of view of your orals, because a lot of cross questions are asked on that. Okay, so please somehow or the other manage to remember all these, okay? Because they can ask you what is a fully charged cell and what is the difference between a fully charged cell and just the nominal voltage. Okay, after it is fully charged, then if you leave it without it going to be discharged, then very slowly by itself it will come down to 2 volts. Okay, so this is after charging. This is some time after charging if it is not connected to the load, and this is when it is connected to the load and it gets fully discharged. Okay, and we know also that the specific gravity falls. Okay, it is a fully charged cell. That is the specific gravity, and when it is discharged, it is going to be reaching that particular figure. This is an easier figure to remember. So remember this figure for your oral examinations. Okay, so we saw that happening by seeing a video, how your voltage is going to drop, how your particular specific gravity is going to drop whenever you're discharging the thing. Why is the voltage going to drop? We saw is because lead sulfate is forming on both the electrodes. And therefore the interaction, as you saw in that thing, you're having electrons moving this side and that side. Okay, that is not going to happen if lead sulfate is going to be formed. Okay, so that is why the voltage is going to drop. And then we saw during discharge that your already diluted H2SO4 is going to get further diluted by the addition of water due to that chemical reaction. Okay, so that is why our voltage and specific gravity are falling during discharge. And then when you're going to recharge it, we saw that the voltage increases as well as the specific gravity increases for the simple reason voltage increases because both the original electrodes are got back. Also, H2SO4 is created due to that chemical reaction. Okay, so very quickly, those chemical reactions, remember the H2SO4 is diluted. Okay, you do not have pure H2SO4, neither do you have pure H2SO4 as a, in the battery locker, because H2SO4 in its purest form is very, very corrosive. That can get ruptured and then it can eat through the metal. So it is never ever taken on board in the purest form. You will have a diluted form, the 3 parts to 1 part, 3 parts being of water, 1 part of H2SO4. That will be there on board in your battery locker, but not pure concentrated H2SO4. Okay, very quickly, the discharging thing, sequences at your anode and cathode. We saw that your anode PbO2, lead peroxide is converted into PbSO4, plus you're adding water both at the anode and the cathode, and both anode and cathode are turning to PbSO4, lead sulfate. Therefore, recharging very quickly at the anode and the cathode, both anode and cathode, which were lead sulfate, are being reconverted into lead peroxide and spongy lead respectively. Therefore, you're obtaining both your electrodes back to its original thing. And you're seeing that H2SO4 is also being added both at the anode and the cathode. Therefore, your specific gravity is once again normal. Okay. Right. So this is where we left it off yesterday, or rather on Saturday. And let us continue from that point onwards. Okay. I've never sailed on a ship where, because I've been on board the ship as an electrical officer, then obviously I would be doing the job. So electrical officers, engineers also need to pay attention, because sometimes you do not have an electrical officer, and then you as a junior engineer are given this job of maintaining the lead acid batteries. First and foremost, safety first. Mr. Chandan Patel, please mute your microphone. Thank you. Just give me a moment, please. Madam, right. Okay. So maintenance, let it be electrical officer or a junior engineer who is entitled to do this or is given this particular job in case there is no electrical officer on board. Safety first. Okay. Chief engineer has to be informed. Where do you inform the chief engineer? During your toolbox meeting in the morning. Okay. Duty officer also to be informed. Which duty officer? Not the engineer on watch. It is the duty officer on the bridge at that time. Okay, so generally it is done in the morning, depends on from ship to ship, company to company, but generally your Saturday routines are carried out in the morning. So who's going to be on watch during that time till 12 o'clock is the third officer. So the duty officer, being the third officer, would have to be apprised of that. Okay. Wear proper PPE, okay, in your particular places where you have your wet cell batteries, your lead acid batteries, battery locker, and in the emergency generator room, you have the appropriate PPE, apron. Apron would have to be acid resistance, not an ordinary apron. Okay, gloves. Okay, these are also acid resistance gloves. Somebody had told me some time back that they were using electrical gloves. Okay, God help you if you have a inspection on board at that time and they find that they are electrical gloves, straight away a black mark will go against the ship. Okay, that means they do not know what gloves are to be used where. So both apron and gloves have to be acid resistant, because that acid should not fall on your hands, the acid should not fall on your clothes. Okay. Face shield. Okay, you can have splashes that can go into your eye and damage your eyes permanently. Either face shield or goggles. Okay, goggles, if you're going to use goggles, then they are not the chipping goggles. Now, what is the difference between the chipping goggles and this? If anybody has seen, chipping goggles have vents at the side of the eyes, both on the right hand and the left hand side, whereas normal goggles for this purpose does not have any vents. Okay, air vents. So yes, you will get fogging up, but then what is more important, your eyes or the fogging up of your this thing? Okay, so the goggles that are going to be used in this case will be without any vents at the side of those goggles. Okay, then you have to go to your battery room, open the door and wait for 5 minutes. Now this 5-minute waiting is in case there is forced ventilation. Okay, no forced ventilation. Okay, now what do we mean by forced ventilation and natural ventilation? Okay, so generally, let's say this is your battery locker. Okay, here's the entrance. And generally the battery locker is on your bridge deck. Okay, and on the top is your monkey island. And then on top of the monkey island, you have a mushroom. Okay. Generally, you will find always over here a small vent right at the bottom of this particular battery locker. Okay. So when they're talking about natural ventilation, this is always kept open. Also, this mushroom vent is always kept open, irrespective of whether you're a tanker or not. Okay. There are certain things that have to be kept open, irrespective where there are cargo operations or not. Okay. So natural ventilation is air will get in through here, circulate inside your battery locker, and then escape out through this mushroom vent. This is natural ventilation. If you're going to have natural ventilation, then when you are going to open that door, you will keep it open for 5 minutes so that more fresh air gets in and circulates and escapes out. Okay. If it is forced ventilation, that means you're going to be having a fan, a vent fan over here. Then you do not need to wait for these 5 minutes. You can go open the door and go get it straight away because it is pulling in the air and pushing it out. Whereas natural ventilation, it is happening naturally. So it's going to be taking much more time to ventilate or clear this room battery locker of any dangerous gases. Okay. Switch on the flame-proof light. Now inside you have a light. Okay, it is not an ordinary light fitting. It is a flame-proof, generally and intrinsically safe, or as they say, flame-proof safe. We will be seeing that in another chapter. EXD or even EXI also it can be rated. Why is it? Because why are we having such a thing over here? Is because generally during charging, the fumes that are released, one of which contains as hydrogen. Okay, and hydrogen is a very, very explosive gas by in itself. So in case there is any electrical fault in this light, that can, or if a normal light was used, that is, then it would cause a fire and explosion. Also, if you are using forced ventilation, then the motor has to be intrinsically safe. Okay. Also, the blade should be of non-sparking type because sometimes those blades can touch the side of the vent. Okay, so they should be of the non-sparking type. Okay, these are the requirements. Okay, don the PPE and then take the specific gravity without lifting the hydrometer into the air. So whenever you're going to be using that hydrometer, okay, generally it is, I'm going to show it very roughly over here. I'm not an artist, so please bear with me. Okay, so this is your tube. Okay. And from the tube, you're going to have that glass tube, and you're going to have this suction tube over here. Okay. Over here, you're going to have that like an aspirator bulb. Right. And then inside, you're going to have, let me make it with a lighter color. Okay. Okay, so since it's very small, I will just be indicating certain parts of that bob which is there. And right here at the bottom, you have a thing like a glass thing like that. And there is lead filled in over there. Okay, so it depends. There's green, white, and red sections. Okay, so this thing you will be putting into one of those openings of your battery. And this is a maintenance type of lead acid battery. We're not talking about lead acid battery of the maintenance free type. Those are sealed. So you would open those vent caps, then insert this into that particular opening, press this bulb, extract not too much of the thing. It should be such that this bob just rises. Okay, this bob which is having a lead over here, because of the specific gravity, it is going to rise. Don't pull it up so that it gets stuck over here. Okay, this portion that you put inside in one of those openings, do not lift it up, because with the acid and this thing, this thing can hit somewhere and splash that sulfuric acid onto your clothes or wherever. Remember your long sleeve boiler suit. That is why they say wear long sleeve boiler suit. That is not going to be covered by the apron, mind you. So that thing can splash onto your boiler suit. And the next time you wash it, you'll have a lot of ventilation in that boiler suit. Okay. So keep this inserted. And then once you push out, after taking the reading, push out the electrolyte, very carefully then remove it. Don't be in a hurry. Okay. Right. So that is what they mean. Don the PP, take the specific gravity without lifting the hydrometer into the air. Okay. Number 2, visually inspect the batteries. Make sure surfaces are clean, terminals are greased with either Vaseline or petroleum jelly, not with any other grease. Some people put grease. Okay, sometimes I used to go on board and I used to find a brown substance and I used to wonder what it was. People have used grease. Now, on board the ship, grease is used. There are various types of grease. You use the wrong type of grease, or for that matter, any grease other than Vaseline or petroleum jelly, you can have problems. Okay, so don't put ordinary grease, use Vaseline or petroleum jelly. They are that white type of thing that is there. Okay, this you would find in your IMPA code book as petroleum jelly or white jelly as it is called sometimes. Okay, so apart from that, see that the vent caps, the maintenance type of batteries, see that the vent caps, on top of those caps, there is a hole. This allows for any gases that are built up during charging is able to escape, because if it is not able to escape, then pressure will build up inside the battery and the battery can explode because of that extra pressure. Okay. Make sure that the surfaces are clean for the simple reason is over a period of time, dust and dirt and etc., including because of this Vaseline or petroleum jelly melting during the hot season. Okay, it can go around on the surface over there. So number 1, you can have surface leakage currents, if you remember. Okay, it doesn't need to be high voltage. Surface leakage currents can happen even during for low voltage also. So if you're going to have that surface leakage current, there'll be a current flowing between positive and negative unnecessarily, and you're going to be discharging your batteries. Okay, so see that these things are clean. Okay, ensure batteries are topped up sufficiently and not overfilled. Okay, this comes with experience, how much of water, and that too distilled water, not ordinary water. Remember, ordinary water has minerals which can interact during a chemical process. And yes, people say you can use this, use that, paisa bachao, company ka paisa bachao. But what are you doing? You're damaging your batteries earlier than normal. Normally 2 to 3 years, and you're supposed to change your lead acid batteries Instead of 2 to 3 years, maybe within a year that battery is gone. Okay. Blame it on putting normal water. You're supposed to be putting distilled water. That same water that you are generating is distillized. In other words, everything else is removed. It is near 100% pure water. No minerals, no salts in it. Okay. So check the terminal tightness. Okay, you are having several cells that are going to make up the battery. As I said, either in series, parallel or series parallel combination, depending on what. Normally on board our ships, we are having them all in series combination because we want 24 volts DC, right? Whether it is a GMDSS battery or general use batteries, okay? So they will be having interconnections, connecting one cell to the other cell, and then finally all the cells coming together in order to form the 24-volt batteries. Yes, check all the terminal tightness, because what happens if it is not properly tight, then you will not have a proper discharge current flow. Conversely, when you're going to try and charge, then you will not be able to charge all the cells properly. That's why sometimes you will find suddenly one cell going belly up, isn't it? One of those cells won't be taking charge any longer because you're under the assumption that everything is being charged properly. You will find when taking the specific gravity after some time, despite charging your batteries, that the specific gravity is not coming up only. Okay. So maybe it is because of terminal tightness, because as we saw, if we do not recharge the battery, then that lead sulfate is going to remain, and then no matter how much you charge it, nothing is going to happen. Okay. So that is with regard to point number 4. Check all the terminal tightnesses and see that they are proper. Point number 5, load test. Okay, we saw this earlier over here. Rules require that the normal charging, when I say rules required, this is for your GMDSS batteries, okay? GMDSS, not so much for your general use. Okay, the normal charging facilities are to be such that a completely discharged battery can be recharged to 80% of its capacity. Now, what is 80% of 24 volts? Just let's calculate. 24 into 80%, that is 19.2 volts. Okay, so this should be 19.2 volts. Okay, in not more than 10 hours. So all the cells of the battery have discharged to 1.8 volts, as we saw. That is a fully discharged thing. Okay. Okay. So when you're charging it, it should reach 80% of 24 volts in not more than 10 hours. Okay, and that is what they are meaning here by this particular point. Okay. The load test. Using a load tester, you can have, sometimes they have it on board, but if you do not have this load tester on board, then you should connect all your, as I said, this is mainly for your GMDSS batteries. Then you switch off your AC, whereby everything switches on automatically to your GMDSS battery source. Okay, and then keep all the equipment on so that all those equipments will start discharging your GMDSS batteries. Okay, and it should not drop below 12% of the rated voltage. Okay, now 12% of the rated voltage. Now here they're talking about battery normally rated at 12 volts for one battery or 2 volts per battery. But if you're going to talk about one second, our 24-volt battery, let's take 24. Okay, it should not drop by more than 2.88 volts. So 24 minus 2.88. Okay, and how much is that? That is, it should not drop more than 21 point thing. So it's rounded up to 21 volts. So it should not drop below 21 volts. Okay. So that is the thing. Whenever you're doing this load test or whenever you're discharging your GMDSS batteries, your total voltage when doing the discharge should not drop below 21 volts, because then it becomes very difficult to discharge it. Okay. I mean, charge it again. Okay. Right. These were the maintenance type. Okay. 0.6 and 7 battery should be always kept on trickle charge. We will be seeing the charging circuit. Why trickle charge? Is because your batteries are continuously being topped up. You can have trickle charge, you can have booster charge, and you can have float charge. We will see these three charges when we are doing the battery charging circuit. Okay. Point number 7, use insulated tools to prevent accidental shorting between terminals. Okay. Remember, when you are tightening those terminals, we said all the tightness should be checked. Okay. Use insulated tools so that by accident you do not short any terminals. If positive and negative get shorted by some means, such a high current flows. Remember, what did we say? If a cell is rated at 200 amperes, okay, ampere hours, then those 200 amperes are going to be flowing in that instant. Okay, number one, it is a shock hazard. Number two, such high heat is produced that not only those two terminals of the battery get very seriously damaged, also you will notice that the tool that you are using also gets damaged. Okay, so please always take care whenever you are tightening those terminals. Insulate one of those terminals, put some insulating material between the positive and the negative, and then tighten the negative or then tighten the positive accordingly. Okay, don't take any chances. Okay, this is one of the safety precautions that one has to take. Okay. Now coming to the maintenance free type, remember I said the maintenance type have vent caps. You can open them. You can fill electrolyte, top up the electrolyte. You have to clean those vent caps, etc. In your maintenance free batteries, we don't have these openings. Yes, you can see those openings, but they are sealed. You do not have any vent caps. Of course, there will be a gas relief valve. Normally, that gas relief valve is not easily locatable, but yes, every single sealed battery, maintenance-free battery, will have a gas relief valve, because you are going to be charging those batteries. You are going to have those same vapors that are being formed. And if there's no release, then your battery will explode. Okay. So number one, for these batteries, once again, you're having terminals. Okay, so those terminals have to be properly fixed, tightened, and you will be using again the Vaseline or petroleum jelly for those particular terminals. Number two, battery condition is given by a built-in indicator. Now you have no idea what is the level or what is the charge. You cannot take your specific gravity reading. Then how on earth are you going to know what is the condition of this? Yes, you can take the voltage. Okay, but not always the voltage is the correct indicator. Correct indicator would probably be your specific gravity. Okay, so in order to give that type of indication of whether your battery is good or bad or somewhere in between, you have generally an indicator. Those that do not have an indicator, okay, you just cannot do anything about it. Okay, but generally, you have your maintenance-free batteries having that indicator. Green, white, and red, where green means it is fully charged, white means that it will be requiring charge now shortly, and if it is showing red, then it is in the fully discharged condition. Okay. Point number 3, all precautions for normal maintenance batteries have to be taken. Yes, you wear that apron. Yes, you wear those gloves. Yes, you wear those protection goggles or face mask. Okay. because they are known to explode. Remember, if the gas relief valve gets choked and you're charging those batteries, yes, it can explode in your face. I had a good friend of mine, of course, he's doing servicing of various things, TVs, radios, sound systems. He's even taken on the thing of inverter batteries and inverters, okay, for home use. And it was a maintenance-free battery, which people, whoever had called him for servicing, said, "Hamara inverter kaam nahi kar raha hai barabar." Okay. So when he went to check and all that, he checked the charging thing. Okay. And poor fellow, as usual, anybody in India, they don't have the safety thing in their minds at all. There are no face shields, no goggles, no gloves, no apron, no nothing. Okay. And during his check, that battery exploded. Okay. He was seeing whether the inverter was charging that battery. And that is the time that battery exploded. The poor guy was injured. Yes. He had a lot of burns. Of course, it's not going to burn right through and through because it is diluted, but yes, he had a form of, reddishness, because yes, it is going to, if any, the electrolyte, the diluted sulfuric acid falls on your skin, after some time it itches, isn't it? It's very, very scratchy. Okay, so he had some reddish skin wherever that thing had fallen. It had gone onto his face. Not only his face, it entered one of his eyes and permanently damaged his eye. He doesn't have any sight in that eye today. Okay, so even your maintenance-free batteries, see that whenever you are having that on board, if at all you have it, that all the PPE are still there and that it is being used. Okay, if you're having an inspection and all those things are in its original packing, then again, you're going to get a black mark in your particular this thing. Just give me a moment, guys. I'll just get some water from my throat. Okay, so these are all the precautions and the thing that you would take whenever you're doing maintenance or maintenance-free batteries. Okay. Right, now coming to the charging cell, but before charging of these lead acid batteries, but before that, any queries or doubts on what we have covered up to the maintenance of batteries? Okay, so having seen that, let us see how we charge those batteries. We saw in the video how the batteries get charged. Current flows in the opposite direction. When we say current flowing in the opposite direction, when a battery is being discharged, the current flows from the positive to the negative via the load that is connected to the battery. Okay, when you're charging, you have to have the current flowing in the opposite direction. That means the current will be flowing from the battery charger into the positive terminal. Okay, and then via the electrolyte to the negative terminal. Okay, so it is an internal process rather than the discharging, which is an external process. Okay, so this particular diagram that you are seeing is the most simplest of diagrams for understanding your battery charger. And it is based on this particular diagram that your questions are asked. Number one is, as you can see here, you have trickle charge, you have full charge. Nothing shown here with regard to float charge. Okay, now your particular battery charger will have either the trickle charge or float charge. It's not going to have both. Okay, so it'll have either the float charge or your trickle charge. Okay. Now, what is trickle charge? You have to, during your charging process, you have to be supplying voltage to your DC battery or to your bank of batteries. So a current is going to be flowing, a charging current. Now, when you're having trickle charge, if it is switched to the trickle charge, you are seeing here is actually not a resistor, but they are showing a resistor because this resistor indicates that the current that is going to be flowing in this particular position is going to be a very, very small current. Okay, that is why they're indicating a resistor. It's not a resistor, it is a charging circuit that is going to be limiting this current. They can't show that in this type of diagram, no? So that is why they're showing it in the form of a bigger resistor. This, as they're showing, as a form of a smaller resistor. Smaller resistor means it's going to be giving a much higher current in full charge or booster charge, as it's called. Okay, let's deal with the trickle charge, float charge, and then come to full charge, stroke booster charge, stroke manual charging. Okay, so trickle charge. Trickle charge is you are giving your batteries continuously topped up voltage. At no time is your charging process stopped. So continuously you're getting, it might be even a few milliamps of current that are going to be flowing in order to keep your batteries topped up at every given instant. That is what is called as trickle charge. What is float charge then? Now in your charging circuit, in your battery charge and discharge panel, it's an electronics unit over there. In the charging process, you will be having a certain cut in and cut off point. Cut in and cut off. Okay. And what did we see? That it should not go plus or minus 12% of the rated voltage. Okay. So what did we say? One was 21 volts and the other one, what is 12% on the higher side? Just give me a moment. So 24 plus 2.88. So that will be 26.88 or rounded off to 27 volts. Okay. So it should not go greater than plus or minus 12% of the rated voltage. And what is the rated voltage? 24 volts. Okay, so it shouldn't fall less than 21 volts. It shouldn't go greater than 27 volts. And who is going to do that? This particular battery charger. So it will cut in at 21 volts. It will cut off at 27 volts. So that is what is called as float charge. So you're not having continuously a current flowing. It will cut in, current is going to flow, charge up the batteries. When it is reached this particular voltage, the charger will cut it off. Okay. And then when it again comes to 21 volts, again it is going to cut in and then it will cut off. Cut in and cut off, cut in and cut off. That is what is meant by float charge. Full charge means that you're going to give the maximum amount of charging current when this particular switch is closed. Okay, as I said, it is shown as a resistor over here to indicate that this is a smaller resistance. So maximum current is going to be flowing rather than through the trickle charge. So this is basically called as booster or manual charge or full charge. Maximum charging current is given and therefore you cannot take this very lightly. You can't put it on and then disappear. You have to be over there because sometimes the charging current is so large that it has even blown the fuses that are protecting this charging circuit. Okay. And at the same time, and we'll see later on what this charging current, if it's going to be put in the manual condition, what this, or even otherwise, what this charging current can do. Okay, it can be very, very detrimental to your batteries. Okay, although it is required for charging and bringing your batteries back to good health, it can have very detrimental effects on your batteries. And we'll see that a little later. Now, having seen these basics as to what is trickle charge, what is float charge, etc., question that is asked based on this diagram is draw and show. I'm talking about in the orals, gentlemen and lady. Okay, draw and show how would you have your batteries coming on load automatically in case of an emergency, and then going off load when the power is restored. That's when you have to draw this simplified circuit. Okay, so you draw it once, twice, more than twice, and before you know it, you'll know it at like the back of your hand. Okay, very simple diagram. So to start off, okay, you can see that you're having a DC supply. Obviously, you're going to get 440 volts of AC, and this will be coming from your ESB. Okay, note whenever you're going to your ESB to test your thing, you will find this. There is one particular MCCB that is supplying your battery charge and discharge panel. Okay, so 440 volts comes over there. It is rectified, step down to 24 volts DC. Okay, so once it's rectified, it's 24 volts DC that is going to be supplied between these two particular things. Okay. During normal supply times, this 440 volts is being supplied to the ESB via your MSB. Okay, we will see in the chapter of emergency generator how that is happening. Okay, we'll talk about that later. Okay, so when 440 volts is supplied here from your main switchboard to your ESB, you are also getting 440 volts to this line. Okay, so you're getting 440 volts of AC over here. Okay, let's change the VAC. Okay, 440 volts AC over here. Now, this is an energizing coil that is energized by this 440 volts whilst it is present. That is under normal conditions. And what is this coil doing? Once it is getting energized, its core gets magnetized against a spring. And when it gets magnetized against that spring, it is holding on that particular core, which is connected to these two sets of switches. One is this set of switches and one is this set of switches. In the energized position, it keeps both these switches closed and these two switches open. When these two switches are closed, your 24 volts DC in the trickle charge, as I said, normally you do not put it in the full stroke booster stroke manual charge, generally kept in the trickle charge. So your circuit is completed via the trickle charge circuit to the positive of this particular battery, out through the negative and back to that DC source. So your batteries are being kept topped up at every single instant whilst your 440 volts is available. Okay. Now, what was the part of the question that was asked? How does it automatically switch over from your charging process to the discharging? So your emergency load is your discharging process. Okay. Right. So how do these batteries, now they're being charged because these two are closed and these two are open. So nothing is going to your load at this particular moment. It will be connected to your load automatically is only when your main supply fails, or at least until such time your emergency generator does not come on load. When you are going to be having a temporary blackout, this supply disappears. Not only this supply disappears with which this coil gets de-energized and its core gets demagnetized. When its core gets demagnetized, the spring will be pushing it in this direction. Okay, now the spring will be pushing it in this direction, which means now this contact opens out. Okay, this contact opens out, disconnecting it from your charging circuit, and then this contact now becomes closed. Okay, this contact now becomes closed. And now, as you can see, with this being open, your batteries are now automatically connected to your load. Okay, and will start discharging. Okay, so this is your discharge process. Once your normal supply is restored again, okay, 440 volts AC via your ESB, then once again you're getting 24 volts DC over here. Okay, it's rectified, etc. Step down. Then once again, these two, of course, you're going to get your 440 volts at this particular coil, which will get energized, and this time it is going to be pulling. Your core is going to get energized and going to be pulling it against the tension of the spring. Once again, these two close and these two open up. Okay, so no more being supplied. The batteries are no longer being supplied to your load. Once again, it is going to be recharged by automatically switching back to the charging process. Okay, everybody clear with this discharge cycle? Please do practice this particular circuit. It's a very simplified circuit, and you will find that you will have, once you draw the circuit itself, you will understand how it works. Okay, and then you will be able to explain to the exam. Okay.
Full charge because
Sorry, your voice is getting interrupted. I think your internet is not proper. Repeat your question. Let me try and understand. No, I'm sorry. Your voice is getting interrupted. Put it on the chat. Then I'll see. Okay. Put it. Write your question on the chat, and I'll see what you want.
Sir, I think he is asking how to working full charge.
How do you work it on full charge? Okay, so if you put it on full charge or booster charge, or as I said, manual charge, then this switch is closed. Okay, they are showing it as a smaller resistance over here. In other words, that circuit is such that it will allow maximum current to flow in this direction. Okay, through your batteries and back to the source. Okay, there is a manual switch over there on the battery charge discharge panel. You might have seen it. Okay, and generally you do not put that. You always keep it to the trickle or float charge that I mentioned. So if you're going to keep it on the trickle or float charge, then instead of current being in this direction, the current will be through this direction and the same way back. Okay, so this is your full charge or booster charge or manual charge if this switch is turned to the booster stroke manual charge stroke full charge position. And that means it is going to be closing that. As I said, don't get confused by the resistor. It's not it is shown here as a resistor, but it is a circuit that would either allow less current to flow when it is in the trickle charge or maximum charging current to flow when it is put into the full charge position. Let's see, he's put the question on the chat. Let's see, full charge and trickle charge. Okay, what exactly you want me to explain again with the full charge and trickle charge? I have already mentioned it again just now. So I hope your query has been answered. Okay.
Yes, sir. Thank you.
Okay.
There is magnitude of a float charge is magnitude of current. for float charge is between trickle charge and full charge?
Yes, that depends on how much your batteries have got discharged. Now remember, if your batteries are fully topped up, okay, let's say it is fully 24 volts DC, okay, or it has reached that 27 volts DC, then you need very little current. So this particular trickle charge, that circuit is going to give the very minimal amount. It will be in terms of milliamps, okay. But if your your voltage has dropped to say 22 volts, okay, 22 volts. That means if your trickle charging circuit is going to say, oh, it is dropped below this, so let me make more current flow through this and bring it back to at least 24 volts, if not higher. Okay, it should not cross this. So that particular circuit during your trickle charging time will give an extra current. So just see, whenever you have discharged your GMDSS, or for example, you can take even your normal general use batteries. Suppose you've had a blackout, or you somehow or the other are discharging those batteries by some means in order to check this charging current. When you, excuse me, when you put it on the trickle charge and put those batteries back on charge, you will see that the current meter over there is showing much higher. And then as these batteries are getting topped up towards this 24 volts, you will find maybe it's generally an analog meter. Initially, the current will be say about 10 amps. And then very slowly it will start dropping towards 1 amp and even less than 1 amp. Okay. And then when it is it will be so low that you think it is actually 0 amps. Okay. But there is still a very, very small current, which obviously on this particular meter, you can't see. But if you disconnect the thing and put your multimeter in milliamps across that in series, you will see that it is still giving a charging current, but a very, very small current. Okay. So this happens automatically. Your battery charge and discharge panel is completely automatic. So the trickle charge that is going to be flowing will be also adjusted accordingly, either more current or less current, depending on how much your batteries require to be charged. Okay.
Yes, sir.
Right. So that was your charging and discharging process using that particular circuit. Now we come to the alkaline batteries. The nickel cadmium batteries on board ship, if ever they are used. Generally, whenever you join a ship, you may or may not, and mostly you may not find these on board. We will come to the advantages, disadvantages, and why generally alkaline batteries of the wet cell type are not used on board. Okay. Just as we saw in high voltage, you would find generally your VCBs rather than SF6 circuit breakers, right? Okay. I told you the reasons why. Likewise, here also, you will generally not find alkaline batteries of the wet cell on board, and we'll come to that shortly. First and foremost, once again, the parameters. Okay, here they are showing a total voltage of 9 volts. Suppose you want 24 volts. Okay, each cell, this is the nominal voltage. Okay, nominal voltage. So if the nominal voltage is 1.2 volts, so if you're going to get or want a 24 volt cell battery, then 24 divided by 1.2 volts, you will require 20 cells. Okay, 20 of those cells. Okay, 20 numbers connected in series. Okay, all connected in series. 20 such numbers. Whereas 24 volts, using your lead acid battery, this is 20 numbers for your alkaline batteries. For your 24 volts, using your lead acid batteries, what did we say was the nominal voltage? Nominal voltage was 2 volts. So 24 divided by 2, you need only 12 batteries. Okay, 12 batteries. So your alkaline batteries require 8 more such cells as compared to your lead acid batteries. So see all these cross questions. We will go through all these parameters and see all the cross questions that can be asked to you. Okay, what are the advantages, disadvantages? We'll come to that. So this is one of the first disadvantage of your alkaline battery over your particular lead acid battery. You require more number of batteries, and when you require more number of batteries, you need more space in your battery locker. Okay, and everybody knows how compact and small spaces are on board the ship. If you're going to have a separate or bigger battery locker, that means somewhere else they're going to cut the space. Okay, so 1.2 volts per cell as compared to 2 volts per cell being the nominal voltage. Therefore, you would require for the same 24 volts, you'll be requiring more number of cells to make up those to make up that voltage. What is the fully charged cell? 1.5 volts. Okay, more correctly 1.6 to 1.8 volts. As I said, even 1.5 volts is taken as the correct answer in your exam. Fully discharged cell 0.8 to 1 volts, more correctly 1.4 to 1 volt. This is also acceptable, no worries. Okay, now pay particular attention to points 4 and 5. Specific gravity of a fully charged cell, very same as that of your lead acid batteries. Okay, of course, more correctly this, but 1280. Please remember, whenever you're telling the examiner the fully charged or a fully discharged specific gravity, whether it's lead acid or this, please mention the decimal point. We are very used to saying 1280, 1100, etc. But please mention the decimal point. Be very correct in your answering, okay? Yes, he knows what you are meaning, but then he wants to know whether you know what you're talking about. So 1280, make sure it is 1.280. Okay, be it your lead acid or this type of battery. Then note point 5. Specific gravity of a fully discharged cell does not change that from a fully charged cell. Okay, so a fully charged cell is showing this. Fully discharged one, okay, I've already got it there. So your fully discharged one is also showing this. Now the question that is asked in your orals, how do you determine that your alkaline batteries are in good condition or not? Okay. How do you determine whether your alkaline batteries on board your ship are in good condition or not? Fully discharged, 1280, fully discharged, also showing you that. Okay, so your answer would be a fully discharged cell will show you also 1.280 fully discharged thing if it is in good condition. Because if it was in a bad condition, then this particular 1280, even in the fully discharged thing, would fall to 1.190 or even less than that to 1.145. Okay. So if your thing is in a good condition, whether it is fully charged or fully discharged, it would still show 1.280. If it was in a bad condition, then this 1.280 in the fully discharged thing would fall to 1.190 or even less to 1.145. Okay, if it has fallen to 1.190 specific gravity, then you can recharge it and try and see whether it reaches 1280, and then your voltage also you have to monitor whether it goes up. Okay, we'll see the particular chemical reactions and how your voltage also can go up. Okay. But if the specific gravity has fallen to this particular figure, then what is your action that you're going to do? You require to change your electrolyte. Okay. You have to change your electrolyte with that particular specific gravity of 1280, or more correctly, as I said, 1.280. And then charge your particular alkaline battery and then see whether it comes up to this or at least the nominal voltage. Okay. So that is how you would answer your examiner, how one would determine whether your alkaline battery is in good condition or not. Okay. Everybody clear? Okay. So having seen that, point number 6, internal resistance of the cell is very less, much lesser than that of your lead acid battery. Remember, each equipment has its own internal resistance. We spoke about internal resistance in the sensors. Every single thing has its own internal resistance. And if the resistance is more, then you will have a voltage drop across that, means current is going to be flowing through that resistance. That resistance is going to get heated up. And that resistance which gets heated up is going to be a loss of energy. Your particular battery gets discharged through that resistance. So if this resistance is going to be less, okay, your battery is going to be lasting even longer. So internal resistance of the cell is very less, even lesser than that of your lead acid battery. Due to low internal resistance, they can also be operated at very high charge and discharge rates. Okay, remember, whenever a current is going to flow through a resistance, that resistance gets heated up. Okay, so if that resistance is going to be less, then obviously the heat that is dissipated during the charge or discharging process, that is going to be much less. Okay, so here are the other questions that are asked. Why are alkaline batteries not generally used on board? That is why I started off with the very first thing. As I said, 1.2 volts as compared to 2 volts nominal voltage for your lead acid batteries. And when you're going to have that low a voltage per cell, then as we saw, it would require much more cells to make up that given voltage. So for 24, for your lead acid, okay, lead acid ones, you require 12 cells for 24 volts. For your alkaline, you require 20 cells for 24 volts. Okay, so more number of cells. That is one of the main things. Okay. Number 2, it can be in conjunction with this next question. Why are alkaline and lead acid batteries not kept in the same room? Suppose you have this lead acid batteries and you have alkaline wet cell batteries on board. They cannot be kept in the same battery locker. Refer those who have DT Hall, refer to page 144, or maybe newer versions will be having it somewhere around this particular thing. But you don't need to go to DT Hall for this. Use common sense. Why I say common sense? In your ship, when acids are kept in that chemical locker, as they are talking about, generally it's kept in their steering gear room. Your acids are kept to one side, your alkalines are kept to another side, isn't it? They are kept separate. Why are they kept separate? Okay, for one, any gases that are being emitted by them, they do not mix, because if your alkaline and acid batteries are kept in the same thing, they are going to be emitting gases while charging. And if they get mixed up, they cause what is called as an electrolytic corrosion of metals. In other words, the terminals of your battery start getting corroded. They get eaten up. When they get eaten up, proper connections cannot be made, and then your batteries will deteriorate. Both lead acid as well as the alkaline. Also, if lead acid contains the sulfuric, diluted sulfuric, no matter how diluted it is, comes in contact. So if acid comes in contact with alkaline contents, that is why I said use common sense. Think of your chemical locker on board ship. Acids are kept separate from alkalines. Okay. So if they come into contact with each other, remember, in case you are charging and you've topped it up to more than the required amount, then they can spill. They spill, they can come in contact. Once they come in contact, then tremendous amount of energy is released, and then you can have an explosion also. Okay, so very, very dangerous. If you're going to have both alkaline and acid batteries on board, then you will have two separate battery lockers. One for acid, lead acid, and one for alkaline. Okay, and definitely they will also be spread apart, because your vents at the top, your mushroom vents also should be separated. They can't be side by side. Okay, so maybe your battery locker for the lead acid will be on the starboard side, and your other one will be on the port side. So there will be quite a distance between both of them, so that those gases again don't mix up. So see all the disadvantages. Okay, right. So please remember once again all these particular parameters, because as I said, there can be a lot of cross questions, and one of the biggest or the most commonly asked question is, how do you determine whether your battery, alkaline battery, is in good condition or not? Let's say you have not used it for some time. Okay, how do you determine? So whether it is charged, fully discharged, it should always show 1.280 as your specific gravity. Okay. Right. Any queries or doubts before we carry on further? Right. Just as we saw for your lead acid battery, the electrodes, the electrolyte. Here also we'll see the construction and working of the nickel cadmium. In other words, your alkaline battery, your electrodes, your electrolyte, and what happens when it is being discharged, and then what happens when it gets recharged. Okay, your particular nickel cadmium has two plates, the active material of the positive plate, which is the anode, and this one here is the anode. Okay, NiOH4. NiOH4 is nickel tetrahydroxide. Okay, and the negative plate, the cathode, is plain cadmium. This is your cathode. Okay, so that is cadmium. So nickel tetrahydroxide as the electrode, which is positive, cadmium being the electrode that is negative or cathode. Okay. What is the electrolyte? Your electrolyte is a solution of potassium hydroxide with a small addition of lithium hydrate. Now, lithium hydrate is not exactly taking part in the reaction. It is increasing the capacity and the life of the battery. So, in other words, this is acting like a particular, what did we call that thing in that when we are doing the portable gas detection equipment? This particular chemical is called as a catalyst. It helps in the reaction, but does not take part in the reaction. So what is the reaction? That it increases the capacity and the life of the battery. Okay. But basically, we are talking about KOH, which is potassium hydroxide. Okay, so we have seen what are the electrodes, what is the electrolyte. Now let us see the discharging process. What happens when that alkaline battery is discharged? Just as we had H2SO4, okay, and H2SO4 was divided into positive hydrogen ions, okay, and sulfate ions, they were negative. Likewise here, your KOH is also separated into potassium, being the positive ions, that is why it has got a positive sign over there, and hydroxyl ions, which are negative in charge. Therefore, it's got the negative sign over there, okay? So these two things are going to be taking part in this reaction. And how does it take part? What happens at the cathode and the anode? Cathode CD, cadmium, reacts with the hydroxyl to give you cadmium hydroxide. And at the anode, your nickel tetrahydroxide reacts with the positive ions of potassium to form KOH, which is already your particular electrolyte, and nickel hydroxide. So from NiOH4, it's coming to NiOH2. But notice this, during your discharge, KOH is being added. So therefore, even during your discharge, your specific gravity remains as 1.280. Unlike in your lead acid batteries, water was being added to an already diluted solution. Therefore, your specific gravity is falling over there. Here, your specific gravity remains the same, constant. Okay, because you're adding KOH to the particular this. Okay. Right. So nothing happens to the electrolyte, thus the strength of the electrolyte remains the same, unlike that of your lead acid batteries. Here, your cathode and anode are changing, and because they have changed from the original, that is cadmium and nickel tetrahydroxide, your voltage also drops. And what is the voltage dropping to? We saw from those parameters, it drops, if it is fully discharged, to 0.8 to 1 volt from 1.2. Nothing much, but still a drop nonetheless. Okay, so that was your discharging. So obviously we cannot keep it in the discharge thing. Yes, you can keep it discharged for a long period of time, but it is better to charge and keep it. And what happens, at least on board, I'm not talking about a show. Okay, so charging, let us see what happens. Now, it has to come back to its original, isn't it? Original cathode, original anode. So your nickel hydroxide reacts with the negative ions of OH, hydroxyl, giving you back your original anode, nickel tetrahydroxide. This is hydroxide, tetrahydroxide. Okay, Terra 4. Okay, so that's why tetrahydroxide. Hydroxide. Cathode, cadmium hydroxide reacts with the positive ions of potassium, giving you back your particular cadmium cathode, and once again your particular potassium hydroxide. Okay, so that is why your particular charging and discharging process, you have no change in your specific gravity of your electrolyte as far as your alkaline batteries are concerned, wet cell batteries are concerned. Okay, so let us now see the advantages of your nickel cadmium battery. Just as I said in the high voltage class, that we have advantages of your SF6 circuit breaker. We saw the advantages were tremendous, but yet the disadvantages put it at a real disadvantage. Likewise, we have good advantages for your nickel cadmium battery, but just the disadvantages don't really find favor of it being used on board the ship. As I said, not to say that it is not used on board ship. People would prefer that your lead acid batteries are used over that of your nickel cadmium. What are the advantages? Let us see. Number one, it has a very long active life. That means when it is connected to circuits and it's working for you, it works for 20 years without any problems generally. Our lead acid batteries in comparison, okay, yes, at one time they used to accept 5 to 8 years, but now today, whether you like it or not, within 2 or 3 years, those batteries have to be changed. GMDSS, your general use, your particular lifeboat batteries, your emergency generator batteries, all have to be changed within 2 to 3 years of them being installed. Whether they are in good condition or not, it comes up in your plant maintenance system. These batteries are to be replaced. So you get it and replace it. Okay. Point number two, since the specific gravity of the electrolyte KOH does not change, it can be stored indefinitely, either in discharge or charge state without suffering any ill effects. So whoever is selling the battery to you on board the ship, whoever is the battery dealer, he can keep it for years and years and years without any problems. Okay. Point number three, it can withstand peak rates of discharge and charging up to 20 times the normal operating time. We saw that why is because its internal resistance is very, very low. They have very low open circuit losses, so no current is going to flow because of that low internal resistance. Whereas your lead acid battery does have that internal resistance, which is much higher than that of your nickel cadmium batteries, and therefore over a period of time, if you have charged that particular thing and it is not connected even to a circuit, then it will be discharging through that internal resistance. Okay. Point number five, the effect of high discharge rate and low operating temperature is very low on the capacity of the battery as compared to any other rechargeable battery. Okay. What are the disadvantages? And note the disadvantages are very less. But as I said, they act as a real disadvantage for having a alkaline battery on board the ship. Number one, very expensive. Okay, I'm not sure what are the costs, but if it's going to be $100 for your lead acid battery, then it will be at least 3 or 4 times the cost for your nickel cadmium. You just take your normal dry cell batteries. Okay, you go and buy a normal ever-ready battery from the shop. How much does it cost you? You go for an alkaline battery and buy it from the shop. How much more expensive it is? Okay, you would have probably ordered on board from your IMPA code book. And then they give the quote, isn't it? And then sometimes the chief engineer says, "Arey, Bati Saab, ye batteries chahiye ki nahi?" And then they say, "Yeah, Bada Saab, yes, we require these because, okay, we want it for this use." And then very reluctantly, because he has to answer to the company, the company has a budget. Okay, so your alkaline batteries, whether they are dry or wet cells, they are vastly more expensive than your lead acid batteries or your normal dry batteries. Okay. Number two, the EMF developed by a fully charged cell is only 1.2 as against the 2 volts for your lead acid battery, and therefore number of the batteries increases. Therefore, you require more space. Point three, its ingredients are harmful, and this is the biggest disadvantage. Okay. Biggest disadvantage, its ingredients are harmful for the ecosystem. Therefore, its production utilization is banned in some countries. Okay. So when it's going to be banned in some countries, then if you want to get that particular thing replaced at that particular country, and it is already past its service life, for example, okay, you will not be able to get it. Especially your Scandinavian countries, they have banned this particular thing. Okay, so you will not be able to get these batteries in some of these countries. Okay, so even if you have to transport it from somewhere else and you're in those countries, they will prevent it from getting into the country. Okay, so three very small disadvantages, but they are big enough to prevent you or whoever is running the ship from keeping your particular alkaline batteries, wet cell batteries, as compared to your lead acid wet cell batteries. Okay. Let's see the regulations for batteries and the battery room as per SOLAS. Okay, battery room should be easily accessible, whether if you're going through the accommodation. Yes, one goes through the accommodation, gets out through the bridge, and then you have access from that side. Or you have your companion ways from coming right from upper deck right up to the bridge from external of the accommodation, right? So easily accessible from both directions. Number two, battery should automatically come on load in case of mains power failure. We saw from that battery charging, discharging diagram that we saw. Okay, that very simplified diagram. Point number three, terminal voltage should not go beyond plus minus 12% of the rated volt during the entire charge discharge period. Okay, that we saw. And if it is on the float charge, how your float charge controls that. Okay. Point number four, it should be capable of supplying power for lighting at muster stations for at least 3 hours and balance lighting for at least 3 minutes. So your priority is for your safety, and whenever abandoned ship thing is given, then yes, you cannot say that, you know, for 3 hours you know, it is segregated from the other emergency lighting. Okay, but yes, your battery should last for at least 3 hours. Okay. For passenger vessels, it is different. You'll have to refer to the SOLAS dependent on the what is the capacity size of that particular ship, etc. Okay, so they will say so many passengers per vessel. Then obviously it'll take more time to abandon such a big ship. Okay, so probably that particular lighting for that should be for the emergency or muster stations will be much more than 3 hours. Okay, definitely it'll be more than 3 hours. We will see in emergency generator also for passenger vessels and for your normal vessels, the difference between how long your emergency generator should be able to generate. Okay, in case of an emergency. Point number 5, the battery room floor plate should have acid resistance paint up to 150 mm height. Now, what are they talking about this paint? Okay, so generally we have the deck green, and I'm going to indicate that deck green over here. The chief officer uses ordinary paint. That is why I said deck green. Now, this is not acid resistance paint. Why do we need acid resistance paint on the floor or on the deck of your battery locker? Because in case there's any spillage, then this paint should resist that particular acid. Because if it is not acid resistant, then it can eat through the paint. And what is below the paint? Nothing but your plain metal. So it can eat into that metal and cause a hole. And you generally are not supposed to have holes in your deck. Okay, that all leads to, in case there is flooding on board, then your ship can go down very easily. Of course, this is right at the top of the ship, but nonetheless, okay. So not only acid resistance paint on the deck, what are they talking about this 150 mm height? It is this skirting. In your rooms at home, you have your floor, your tiles on the floor, and then the from the floor onto the wall, you have a skirting. No, that same tile is fitted on by about 6 inches or 4 to 5 inches from the floor onto the wall. That is the skirting, and likewise here also that same acid resistance paint that is there on the deck is also painted up to 150. Okay, why 150 mm? That's quite a big this thing is because in case you have your electrolyte that is spilled over onto this and is sloshing due to the rolling and pitching of the thing, then yes, it goes up, no? It goes up onto the deckhead, okay, or the bulkhead, okay? And if this is not acid resistance paint, then it will once again corrode the metal that is there, okay? Whatever the paint, normal paint, it will corrode that paint and then eat into the metal on the bulkhead also, okay? So that is what they're meaning, paint, acid resistance paint up to 150 ml. Just give me a moment, people. I'll be back with you shortly. Okay, so now point 6. So constructed to prevent spillage of electrolyte and emission spray. Okay, so it is kept into trays, etc. You are seen on board. Okay, point number 7, batteries are to be contained in trays to prevent spillage of the electrolyte. Yes, generally we have those batteries in that tray, metal tray, and then you have some wooden chocks only to keep them in place. Actually speaking, lead is to be covering that. The tray is generally made of wood and generally that should be covered internally by lead. Because if you're going to have just plain wood and those wooden chocks to keep them in place, then if there is spillage, your wood will get not exactly eaten up, but whenever there is electrolyte or any liquid falling in that wood gets soft, isn't it? And then that will fall onto the deck and cause corrosion, okay? So generally lead is kept inside over there. I have not seen that on too many ships. I think neither would you, but okay, fine. This is what we need to tell the examiner in case they are going to ask you. Okay, so don't forget that lead has to be on the inner coating. So suppose your particular tray was made of wood like this, okay? Then internally it has to be coated with lead. Okay, so I'm going to show the lead with a gray color because lead is gray, which has to be like that. Okay. Of course, if your thing is already made and then you cannot, because normally the wood that is over there is inside a metal tray. Okay, a metal this thing enclosure like that. And if you're going to put that plus your particular lead inside, then your batteries which are supposed to be fitting within that will not fit. Okay, so you'll have to take a call on that. Okay. Right. Point number 8, if battery bank total voltage is greater than or equal to 20 volts, then insulated stands must be provided all around the tray. In other words, that metal tray is there, and as I said, you have that wooden thing which is there. Okay, which are going to be containing the thing. So that is that insulation that they are talking about. Notice of no naked lights frame placard should be prominently displayed. Okay, remember as I said, when we are talking about the battery locker, okay, and we had the door, then generally that particular notice is displayed over here on the door. It is very conspicuous. You cannot mistake it. No naked lights or flames. Remember I said inside you can have very explosive gases. That is why the light fitting that was there was also explosion proof or flame proof light fitting. Okay. So that is why no naked lights or flame. Generally, this light fitting, as I said, is EXI, explosion proof. Okay, or intrinsically safe. EXII, and we will see from another chapter that I'll be taking with you all these particular terminologies, EXI, EXD, etc., etc. So this one particularly has EXI2C, and we will see what all this means when we are taking up that chapter. Switch for this light should be located obviously outside, not inside. Okay, remember a switch on and off. Whenever you're going to switch off, there can be some spark that is created between the two circuits, the moving contact and the fixed contact, and you can have arcing over there or a spark created. And that spark, if it is going to be, if that switch is going to be on inside, that can be enough to ignite the hydrogen or any other explosive gases that can be there. Okay. And we talked about the ventilation. If it is the natural type, as I said, you have the opening here, whether it is natural or forced. You have a vent here and you have the mushroom on the top. Then if it is natural, okay, you will have this particular thing. Exhaust should be at the top in the form of a mushroom vent or sometimes a gooseneck also. Okay. And your inlet, which is going to be right here at the bottom. And if it is forced, means you're going to have a motor over here, and that motor would have to be intrinsically safe. Also, your blades of the fan should be spark proof, okay, or spark free. It should not be able to, because sometimes if it touches the vent, then it can emit sparks, okay. So those blades should be spark proof. Point 12, battery shall not be placed in the accommodation. Okay, never is it to be placed, even if you're going to be receiving it on board as part of your replacement thing, and if you are expecting some what is that called, inspection that particular day, then always out of sight is out of mind. Okay, so take and keep it either directly into your battery locker, where of course the guy would need to secure it. Don't keep it lying around. Okay, so all these things, all these points are noted by the inspector who is going to be boarding the ship. Okay, in case you're taking stores and having an inspection on the same day. Okay. If load supplied by the battery is greater than 2 watts, batteries are to be kept in the battery room or designated space on deck, room or space on deck. Point 13. If load supplied is between 0.2 and 2 kilowatts, batteries can be stored in the battery room, designated space room, or even in the machinery space. Generally, you will never ever have it over there. Okay, for the simple reason that your machinery space can become very hot. When you're talking machinery space, the only machinery space that you have on board is nothing but your engine room. Okay, so heat has a very detrimental effect on your batteries, and we will see what is that detrimental effect. Point 14, if load supplied is less than 0.2 kilowatts, it can be kept in any one of the above mentioned places. Point 15, all PPE for maintenance purposes shall be made available at all times wherever you have these storage batteries, your wet cell batteries. Acid resistance apron, acid resistant gloves, face shield or goggles, as I said, and don't forget your eye wash. It does not need to be that medicated eye wash that you get from your medical stores. A plain, simple water bottle. Okay, plain water, your distilled water, whatever you want, you have to have that bottle as a separate thing. Okay, any water to flush out your eyes. Okay, on chemical tankers, if anybody's been to on a chemical tanker, you would have had seen on the deck, you have showers from fresh water. You have your eye wash things also over there. Why? Is so that if it has fallen accidentally onto you or gone into your eyes, you can flush it out immediately. Okay, so that is why you have to have this. I do not know, for some reason till today, for your lifeboat batteries, they have the same dangers of any of the other batteries located in your battery room or your emergency generator room, but yet we do not keep these apron, acid resistant glove, face shields, etc. over there, including your eye wash. Okay, and nobody has mentioned that. Maybe sometime in the future, someday, some bright spark will remember that and make that compulsory. Okay, then you'll have to see how you fit those particular things in your lifeboat also. Okay. CCA. CCA stands for cold cranking amperes. Now, what is cold cranking amperes? The very fact that the word cold is used, okay? The word cold is used means you're talking about cold conditions. Okay, remember your emergency generator, that emergency generator room is not a very warm place, even in the coldest of winters. Yes, sometimes they provide heating and all that over there. Okay, but even in those conditions, your emergency generator needs to be started up and come on load within 45 seconds, irrespective of what the weather is. Your lifeboat batteries, certainly your lifeboats are not warmed up. You need to abandon your lifeboats, and those lifeboats have engines that are going to be started up by those batteries, and those batteries need to start that engine and escape from that ship. Okay, whatever the conditions, and we are talking about cold conditions in particular, because in cold conditions, even your car battery also sometimes you are unable to crank and start up your car in very severe conditions. Okay, so what is cold cranking amperes? So cold cranking amperes is a measurement of the number of amps a battery can deliver at 0 degrees Fahrenheit for 30 seconds continuously and not drop below 7.2 volts. 7.2 volts, that is from 9 volts. Not 9 volts, from a 12-volt battery. If they're talking about a 12-volt battery, then that battery voltage should not drop below 7.2 volts. Okay? So, battery that is having a high cranking, cold cranking ampere, this thing rating is very, very important. Okay, so all your lifeboat batteries, your emergency generator batteries will or should have a higher cold cranking capacity. Okay, so that even in very adverse cold conditions, those batteries can start up the equipment that it is supposed to start up. Okay, so if you are going to see the batteries that are there for your general use, your batteries that are there for your GMDSS, they are not being used to start up equipment, such as your emergency generator or this thing. Okay, so they don't need to have high cold cranking amperes. You are using the batteries, these batteries that are having high CCA would be for starting purposes. Okay, for starting purposes. And that is why these batteries for your lifeboat and your emergency generator will be having a larger CCA value. Okay, so everybody is clear with what is CCA, cold cranking amperes? Okay, so I had mentioned that temperature has a very detrimental effect. And when we are talking about temperature, we are talking about high temperature. High temperature has a very detrimental effect on your batteries. Okay, your lead acid batteries, alkaline batteries, but generally we are talking about lead acid batteries because as I said, we hardly find your alkaline batteries as a wet cell batteries on board ship. So what are these temperature effects that happen? Number one, chemical reactions are more vigorous than normal. Thus, voltage rises to some extent. We saw that your particular batteries, whenever they're being charged, they become warm. Not only warm, sometimes quite hot. Okay. So what is the effect of that? It is going to increase your specific gravity. It is going to increase your voltage also. Okay. Number two, resistance of the acid in the battery decreases, which actually helps in these chemical reactions being more vigorous. Better diffusion of the electrolyte, all help one another. So what happens due to all this and the high temperature? Capacity of the battery increases. So yes, it's helpful, but only to a certain extent. We cannot allow the temperature to continue to increase because of, number one, acid attacks the antimony, lead antimony alloy grid. Now, what is this lead antimony grid? Okay, so I'm just going to draw it roughly. You would have probably seen if you had paid attention in your particular to that particular lead acid battery video that I showed. You have probably seen that there is a sort of a latex like thing, okay, for your positive as well as for your negative electrodes. Okay, so I'm just showing it like this, and you would have probably seen almost a similar thing. And your particular lead, spongy lead and your lead peroxide are within this lattice, which is made of lead antimony grid. So basically your electrodes are within this particular lead antimony grid. And what can happen is the acid attacks this grid, and when this grid becomes broken, it allows both these plates, due to the thing, they can bend. You remember what we spoke about when we were talking about those sensors? The bimetallic strip, when it gets heated, it can bend. So also can your lead and your lead peroxide electrode bend because of this extra heat. And if they bend, due to the damage of this lead antimony grid, they can start shorting internally. Okay, and then as you know, if it's going to short internally, there's going to be a high current flow that is going to increase that current even further, the heat even further, and then that's very, very bad for the battery. The battery starts to expand. The battery expands, it starts bulging. When it starts bulging, then it can obviously burst. Okay. Point number two, causes acid to escape through the vents of the top caps, especially if you have overfilled. Okay, you would have probably seen whenever you are doing the particular maintenance and you're trying to see what is the level of the liquid. If it is going to be a black colored battery, you cannot see the liquid level. If you have those see-through batteries, then obviously the levels are marked. Topmost level and the bottommost level, beyond which you should, the electrolyte should not ever cross. If it has gone beyond the upper level, that means you've overfilled the battery, and you would have seen that there's a bubbling process taking place. Okay. So if that bubbling process is taking place, you have overfilled the battery, then with the vent caps, that is why those vent caps are given for the gases and the thing to spill over, not to be contained within that. So with that particular bubbling of your electrolyte that can come through the vent caps and spill into that tray. And if you're having only wood, then that wood gets soft and it can even go on to the deck head. Okay, and cause corrosion, especially when they are having the deck green rather than the acid resistance deck green. Okay, so causes acid to escape to the vents of the top cap, spilling over and causing other material separators to get damaged. Also corrosion of your deck head. Point 3 causes the collection of sulfate on the plates, thus reducing the battery life, as also causing it to expand, crack, buckle, thus causing shorting of the plates internally. Okay, so a lot of these things, and that is not the end of it. What also happens is battery should not be operated beyond 45 degrees, and at 50 degrees, all battery charging must be stopped, whether it is trickle charge or any type of charge. Okay. Now, why is this being said? I'll give you an example of what happened on my ship. It was the last ship I did, after which I retired. It was such a crappy ship that many things were not working properly. Okay, that's a different story. But I will talk about this particular thing of should not be operated greater than 45 and should not be charged. Your charging process should not, or your battery charge and discharge panel should not be connected to your batteries at this particular temperature. Okay, our ship was at the port of Kuwait. We were in the peak summer season over there. And everybody knows, anybody who's been to the Persian Gulf during the peak summer season, it is a very, very uncomfortable time. Okay, because your AC also does not work properly, because your AC is working on the cooling of your seawater. Your seawater temperature is increasing. Okay, so a lot of things happen when your temperature, outside temperature, is very high. So the outside temperature in the Gulf normally does or should not increase greater than 50 degrees centigrade, because they have to compulsorily close everything, because beyond 50 degrees and the human cannot take it. Human being cannot take it. So therefore it is supposed to be closed, but they never ever declare that thing as 50 degrees. Okay, now coming to my ship, yes, it was beyond 50 degrees. 51 degrees in the shade. Where did I get that temperature? If you go on to the bridge on port and starboard side, you have two sides, no? And you have the temperature over there. One wet cell, one is the dry cell. I'm talking about the dry cell. Okay, that was showing 51 degrees on the shaded side. So on the sunny side, it is going to be much more than that. Okay. If you have seen in your battery locker, you generally have a temperature thermometer stuck over there. Okay, some sophisticated battery charge discharge panels have a sensor in your particular thing, and that is going to be displayed on the battery charge discharge panel. So I had gone on my Saturday routines, and then suddenly I got a call on my walkie-talkie, Bati sahab, jara niche aa jao, inspectors aa gaya. Okay, just give me a moment, please. Somebody had to go. Okay, so what had happened? I had disconnected the battery charger for the emergency generator batteries, and I had come up to the bridge to disconnect that. Okay, to disconnect the batteries from your battery charge discharge panel. And when I got this call, I forgot about that, went down, and by the time all the inspection, etc., was over, I came up and I found at least 2 of those batteries had exploded. Okay, so this is what had caused that. So there were a lot of other problems also that were created because of this very high temperature that we experienced. So please note this, okay, battery should not be operated greater than or beyond 45 degrees. And even if it goes beyond that, then at 50 degrees, your charging circuits must be disconnected. Do not charge your batteries at greater than 50 degrees. Okay. Specific gravity with regard to your temperature, when the specific gravity is generally taken at 20 degrees. Now, nobody has 20 degrees constant around the world. It keeps varying from place to place. Okay, so basically the specific gravity, that is 1.280 that you are taking, is to be at 20 degrees centigrade. So for every 10 degrees rise in temperature about 20 degrees, then you should add 0.007 to whatever that reading is. Okay, so that 1280 that we are talking, 1.280 specific gravity. Then if your temperature is above 20 degrees, say by 10 degrees, so the temperature is 30 degrees over there. So to that 1.280, you should add 0.007 to that reading. Okay, and if any 10 degrees below 20, then you have to minus that 0.007 from that. Okay, everybody is clear? Okay, finally, thermal runaway. Another question is, what do you mean by thermal runaway? Again, the detrimental effect of temperature. So what happens that causes this thermal runaway? Okay. This happens if the batteries are charged too fast. Too fast. Why are today's electrical vehicles, quite a few of them, they suddenly catch fire and burn? Nobody knows why. You've seen a lot of scooters catching fire and, people have all faces saying, "Arey, ye kyo ho gaya aisa?" You've seen a lot of news items. Okay, batteries these days, nobody has the time to wait. Pura full charge. Why are your mobile phones catching fire? Aajkal, within a very short time, your mobiles also are charged very fast. Too fast. What happens when they charge too fast? The current of a fully charged wet cell battery, whether it is a wet cell or any of those batteries that are being used for your EVs, rises out of proportion with the terminal voltage. So what happens when that happens? Okay. This is called due to the heat generated from oxygen recombination, that in turn, instead of causing voltage to increase, actually causes voltage to drop. Okay, because of this recombination due to the heat generation, causes actually the voltage to drop, and whatever is monitoring the voltage, it is saying, "Arey Baba, I am giving charge, so your voltage of your battery should increase. Instead it is falling. So let me give more current." When you're giving more charging current, it's seeing instead of voltage increases, decreasing further. So more charging current is given. And this is going to be like a domino effect. So you know what is a domino effect. One domino falls and then the rest sequentially fall. It just continues to fall till all the dominoes fall. Okay. So this reaches a domino effect or a no point of return effect. And as your current is increasing, voltage is decreasing further. As the current increasing, charging a current is increasing, more and more heat is being produced. And then that is what is called as thermal runaway. There is no stopping it. When this happens, your particular battery catches fire, it explodes, and the vehicle also that is there will catch fire in your ship, yes, it can explode, it can catch fire. And as everybody knows, if it catches fire, then you have a problem on the ship with regard to this particular. So thermal runaway is caused by the batteries being charged too fast, production of extra heat, where that extra heat causes the voltage to actually fall rather than increase. And this continues as a domino effect that finally causes an explosion and even fire on board the ship. So this is what is called as thermal runaway. Everybody clear? Any queries or doubts on this battery topic? Because that ends this particular chapter for today. Any queries or doubts? Please remember to watch the video again, because as I said, a lot of cross questions are asked. Okay, so whenever you're going to be as for your written, no worries. You have the time in your hands. The time is in your hands, how you can think and all, but in your orals, you don't have the time. You have to answer immediately. And so please go through the video again with regard to the battery topic. And please make certain that you will be able to understand the question first and then answer accordingly. Okay. Right then, so that's it. We'll call a halt to today's classes. Okay, and tomorrow we'll be taking a new topic at 11 o'clock. So thank you very much for joining. Take care, and once again, I'll see you at 11.
Sir, have you uploaded this AVR notes on app?
See, I'm not allowed to put any notes or videos nowadays because I believe unscrupulous people are using it in other institutes. They're coming onto the group by whatever means, and they're taking these notes and distributing it to other institutes. Okay, so whatever is taught is being recorded. So you go onto the app. Of course, Dilip Saab will be uploading them, and you go through whatever the lecture is, and that's it. Okay. I used to put the notes, I used to put the videos, which were very helpful. But because of unscrupulous things going on, we are forced to abandon this. Okay.
Sir, but I didn't find this AVR notes, sir, on the app.
AVR, no, there won't be any notes. Whatever I have told you with the notes during the lecture is being recorded. Okay. So you can just go to that particular app and check out whenever I was doing the AVR, check out the date that has been uploaded. If it has not been uploaded, contact Mr. Dilip and he will upload the same. Okay.
Okay, sir. Thank you.
Yeah.